Section 6.8 is about linear inequalities in two variables. Remember that inequalities use symbols like less than or equal to, greater than or equal to. When you go to solve a linear inequality, the way you're going to have to show your solution set is you will have to graph it on the coordinate plane. If you have used the symbols simply less than or greater than, then when you graph your plane, your solution set will be the half plane. The half plane is the set of all points on one side of a line. To show you what that's going to look like, on your graph, you will draw the line that you have done or that you've found, and then you will shade on the other side, one or other side of the line. Okay, and so what that means is any point that lands in the shaded region is going to be considered a solution. So for example, this is a solution, that's a solution, that's a solution. But if you're not in the shaded region, that is not a solution. Also, if you land on a dashed line, not a solution. If you use the inequality symbol less than or equal to or greater than or equal to, then your solution will be the half plane that you have shaded. It will also include the solid line as part of the solution set. So, for example, if you graph your solution, you will graph the line. If you use an inequality with an equal to underneath it, your line will be a solid line. And then you will shade on one side of the line. I'm going to show you how to decide which side of the line you want to shade on. So your solution set will include all the points that are on one side of the line. So anything that landed in the shaded region is considered a solution, and anything that landed on the solid line is considered a solution. That's different than the less than or that's different if it has a dashed line. Remember, dashed lines happen if there's no line underneath. Solid lines happen if the inequality does have a line underneath. So when you do this problem, the easiest way to do it is to pretend that the inequality sign is really an equal sign and to just graph the equation like you normally would. If the inequality symbol is a less than or a greater than, you will use a dashed line. If the inequality symbol is a less than or equal to or a greater than or equal to, you will use a solid line. Once you have the line created on your graph, you have to decide which side to shade. And one way to do that is to use the test point method. So often people will pick a point that's either above or below the line, and they'll substitute that ordered pair in for x and for y, and they'll see if it makes a true statement. If it makes a true statement, you shade that side of the line. If it makes a false statement, then you would shade the other side of the line. Easiest way to explain this to you is by putting it in action. Okay, so we have the inequality x plus 2y is less than 4. Okay, there's a couple ways you can do this. If you want, you can just pick points and plug them in, or you could also solve the equation for y and graph it like y equals mx plus b. It's really up to you. It's just personal preference. Okay, so I would prefer to solve the equation for y. So to do this, I'm going to first subtract the x to the other side of the inequality. So I have 2y is less than negative x plus 4. And then I'm going to divide each side of the equation by 2. So y is less than negative 1/2 x plus 2. So remember that your 2 is your y-intercept. So we are going to start on our graph at the y-intercept of 2. And then our slope is negative 1/2. So that tells me to go down 1 space and right 2 spaces. And you can do that as many times as you want. Down 1, right 2. You really only need 2 dots to create a graph of a line. Now, since our inequality symbol does not have a line underneath and it's just a less than symbol, I am going to use a dashed line. Okay, now I have to decide if I'm going to shade above the line in region 1 or below the line in region 2. One way that you can make that decision is you can do what's called a test point method. So a really easy test point is the point 0, 0. So all you do is, if you choose the point 0, 0, where the x is located, you substitute in a 0. And where the y is located, you substitute in a 0, and you simplify the expression. Well, if you did that, you would have 0 plus 2 times 0. Is less than 4. Well, 0 plus 0 is 0. Is it true that 0 is smaller than 4? You can use the alligator test if you want, where the alligator eats the bigger number. Is the alligator eating the bigger number? This is a true statement. So where the red dot was located is the side I want to shade. So in this problem, I would shade underneath the line. When you're in my math lab, you will have to hit the little paint can in order to get the graph shaded. If you do not shade the graph in my math lab, they're going to mark the whole thing wrong. So just be prepared for that. So here's another example. Draw the graph of 2x minus 3y is less than or equal to negative 6. I'll show you the other method if you want. So if you don't like solving for y, you could always pick points. An easy way to do it is to find your x-intercept. So if you're looking for your x-intercept, you simply substitute 0 in for y. And so you would get the expression that 2x is less than negative 6. So our x-intercept in this problem is going to be negative 3. So we could put a dot on the x-axis, at negative 3. Put it in the wrong spot. You could also find your y-intercept. A way to find your y-intercept is to substitute 0 in for x. And anything times 0 is 0, so that's going to cancel out. And you could solve for y. Your y-intercept is going to be positive 2. So I could put a dot at the positive 2 on the y-axis. Now you have to decide what type of line that you need to use. Because this inequality symbol has a line underneath, or an equal to symbol, you will use a solid line. And then last, you have to decide which side to shade on. So again, pick yourself a test point. Usually 0, 0 is the easiest test point, and substitute it in. Is 2 times 0 minus 3 times 0 smaller than or equal to negative 6? Well, that would give us 0 minus 0, which is 0. 0 is indeed smaller than negative 6, so I will shade on the side where my test point was on. If it came out with a false statement, I would have shaded on the other side. So my solutions are anywhere, any ordered pair that's in the shaded region, and any ordered pair that's on the solid line. So you have infinite solutions. One last problem just to see, okay? This problem is solved for y. You have the equation, or the inequality, y is less than x. So this one already looks like y equals mx plus b. I'm going to edit it a little bit just so it's a little more clear to you. Usually the slope is the number in front of the x. If there's no number listed in front of the x, you would assume that the slope is 1. And typically the b is the number that's being added to the x to the right on the right-hand side of it. There's no b value, so in that case your y-intercept is 0. So if you were going to graph that line, you would start at the origin 0, 0, and you'd use your slope and go up 1, right 1, up 1, right 1. So it's basically going to look like the 45-degree line that cuts through the origin. Okay, you are going to have to decide what line type to use. Because the inequality symbol has a less than and it does not have an equal than, you will need to use a dashed line. So that means any ordered pair that appears on the dotted line is not part of the solution set. Then you have to decide what side of the line to shade. Should you shade above it in region 1, or below it in region 2? You can't use the test point 0, 0 here because you're traveling through 0, 0. So you're going to have to pick some other test point. So I'm going to pick the test point 0, 5. Okay, so if I substituted that in, I would put 0 where the x is located, and I would put 5 where the y is located. And so this would say that 5 is smaller than 0. 5 is definitely not smaller than 0, so that is a false statement. So in this situation, you would shade on the opposite side of where the test point was located. So do not shade on the side of the test point, but shade on the opposite side. And again, in my math lab, you're going to have to use the little paint can to do your shading. Okay, good luck. Let me know if you have any questions.